Okay, let us get going again. And as we get going, we have some supply registers. We have some return registers. Again, the supply is out toward the outside where we think the new conditioned air will do the most good. The returns towards the inside where we're going to draw the deader air that's already been used in and take it back to the air handler. We're ready to put some ducts in here. Okay, so here's how we do that. It's actually pretty easy. Here's how we get started. We want to basically connect these locations on the inside and the outside, back to some place where there's going to be an air handler, some sort of unit that's going to blow the air through and chill it or heat it, whatever's going on. And I'm probably going to, in my building design, think about having that kind of over here in this core space near the stairs and the elevators, a little mechanical sort of area where I probably have some ducts that run up and down and distribute some air to the different floors. But I'm going to basically try to pull back to this area. Okay. The idea is going to be some sort of either mechanical equipment in there, or there's going to be some ducts that are going to run up and down up to the roof or down to the basement, something like that. So I want to connect these back in here. I want to pull some ducts in, and here's how you do it. I'm going to still be looking at the level 2 ceiling plan. I'm going to say, let's go ahead. Well, actually, before we even go there, let's just make sure that things are about on the level where we want them to be. Go back over to the 3D view. You can see, oh, there's some ductwork kind of hanging around in there. There's some registers. They're not looking too bad. Let me rotate it around a little bit. You'll see they seem to be at about 8 feet above the second floor right now. That's kind of doing okay. Let me go through and do this. Let me rotate this around again. And what I'd actually kind of like to do is, in this view, kind of scalp off the top of the building so I can sort of see the ductwork so I can be placing in 3D very easily. So to do that, what I'm going to do is turn on this thing called the section box. Okay, the section box you'll see is just not hiding from us right now. That's all that's really going on. I need to make it visible. See if I can make it visible. Actually, it's the crop region. This is the things that are hidden. Let me unhide it. Just so I can see it explicitly. There's the section box. Now I can push and pull on this thing. The cool thing about the section box is you actually can sort of push and pull it in, these dimensions too. So I can turn it over. Now I have the top of it riding just below the 3rd floor. So if I rotate this around again, okay, I'm going to get a pretty good view of what's happening up there above this kind of space. Again, the grayed out space, that's the linked model showing through. These ones that are more solid, those are the actual returns that we put in. Okay, so I'm going to go back to that floor or that ceiling plan and we'll put some ducts in here. Okay, the duct tool is right up here. The duct tool just chooses a specific thing, very much like running pipes. Type of element, we'll choose the duct in there. We have all sorts of different ducts available to us. We have rectangular ducts, we have oval ducts, we have round ducts, we have all sorts of different kind of ducts available. I'm going to stick with the rectangular ducts for right now. Rectangular ducts, what are they? They're probably the most common one that you see running around. There's this whole notion about, are they going to have elbows, or are they going to have mitered corners? If we put elbows in, what happens is as I run a duct section, as we get any sort of bend, it'll make a nice elbow out of that. The nice thing about elbows is elbows are very nice and efficient. They're nice smooth curves. There's a very less loss of efficiency at an elbow as opposed to a mitered corner. A mitered corner would be more like this, and we have a miter kind of cutting across there. And that hard corner with those corners and edges, and you lose a lot of efficiency across those. So, elbows tend to be smoother. The disadvantage about elbows is elbows take up a lot more room in my limited space than mitered corners. Okay, so there's a trade-off in there. About what you can. You want to sort of fit it all in there, but at the same time you don't want to compromise the efficiency of your system too much. So I'm just going to stick with the elbows for right now. We get to say where we want to put this. I'm going to put it at level 2. and some level above level 2. I'm going to make it like, 9 feet above level 2. Okay. Again, it's always a sort of issue of really where you're putting things. Even there's the whole notion of the vertical justification, the horizontal justification. When I say I'm putting it at 9 feet, that's the middle of the duct. So if I have a 12 by 12 duct, 6 inches will be above, 6 inches will be below. Okay. I'll start just with 12 by 12 ducts. That's a pretty reasonable assumption to get started. As we keep going, you'll see that the system will go through and actually compute the size that's necessary. Because as we get further and further away from the air handler, the ducts can get smaller and smaller. There's less air blowing past. As we get further or closer and closer into the air handler, you take the load of all these individual terminals and they add together, so the ducts get a little bit bigger as we keep on going back. Okay, but for now we'll just kind of work with a single size. That makes it easy. Where I'm going to go through and, I will just start, doesn't really matter which direction I draw it. I can just pull on out. We're not seeing anything just yet. Let me think about why that is. Am I on level 2? I'm on level 2. Maybe I'm just drawing a single, that's what it is. I'm just drawing a single line right there. We'll fix that in a second too. So I got some sort of single line in here. I can either round the corner that way, or I can maybe pull on down and pull in like this. Okay. But I'm basically putting a blue line in there. Okay, let's talk about what that blue line represents. That blue line in every duct, actually I should have shown you before I did it. You choose a system, whether it's a supply air or return air system. This was set to supply. It's a single line right now because at a coarse level, it'll represent it as a single line. At a medium or a fine level, it'll actually show the width of the physical element. So very much like beams and pipes, they did the same thing. At a coarse level, it shows just a single line. If I turn it up, it'll show the actual dimension. And you'll see that the nice thing is, as you go through and around any corner, it puts all those little elbows in, but you can also see that those elbows are pretty big in terms of what's going on. So let me just kind of run another piece for you, just so you sort of get a sense of how it works flexibly. Okay, duct, 9 feet, that's fine. Supply air versus return air. Okay, I'll just run one over to the other side of the building. So I'm coming on down, I make the corner, I make the corner. It'll just kind of keep rounding it out. I'll distinguish that from duct, supply air, but instead of radius elbows, we'll do the mitered elbows. Okay, it squares them all out. Any of those things will work. It's really just, this is a much smoother line, very few bends, much less loss of efficiency. This middle one, it's got those elbows, but it's still a pretty crazy path. By the time we're getting out here, we've lost a lot of the efficiency just due to the fact that all those bends are kind of cutting into the energy. Okay, this one down here, this is probably a very bad sort of design. It'll get the air there, but I'm going to have to use a lot of energy to push the air out where I need it in that kind of a design. So these are all just lines, so I can tab and get rid of them, kind of in the same way, just select them all. I can move them, whatever. It's just like lines, but it's just very much like placing pipes where the lines would turn into pipes. This is more ducts. Okay, now I've got these fantastic ducts. They're looking pretty good. I am ready to start joining things together. I have these terminals sitting there at 8 feet high. I have this sitting there at 9 feet, but splitting 6 inches above, 6 inches below. The truth is, it's hard to actually kind of make the physical connection, because to get an elbow in there in only 6 inches, it's just not really physically possible. It's going to complain about that. So I have a couple different things I could do. If I have a lot of space, I could raise that whole system. Now, I don't want you at 9 feet, I want you at 10 feet or 11 feet. But then again, I might be starting to run into the beams. Okay, so maybe I do or don't want to do that. Another way to do that, what we often do when we have a very compressed space to work with, is we'll actually run little stubby pieces of the duct where it's getting very, very close to the duct or the terminal. But for that last little piece, we'll put in something called Flexi Duct, which is like the dryer hose. It just allows things to connect together in It's not the most efficient connection, but it's a very flexible connection that lets us bend around all sorts of things and really accommodate the fact that if things are 2 or 3 inches off in any one direction, we can handle that very nicely. The problem with hard ducted systems is they're really precise. You know, when you have the sheet metal manufactured and it needs to be exactly here, sheet metal doesn't exactly bend. It's pretty much got a specific location, so you have to be very precise about where the terminals are located. Flexi duct, although it's less efficient, you know, gives you a little more leeway to kind of, if things slipped a few inches. So the compromise we tend to use is if we use Flexi duct, we'll use it for very short lengths. Okay, that's really the way we tend to work with that. So if, for example, I take this duct and get it ever so close, but I'm not going to get it right to the top. Actually, even there, I'm too close because it's touching me. It's touching the arrow, so it thinks that it's joining it in. What I'm doing is I'm going to go through and pull these things very, very close, but not actually get there. Okay, so I got real, real close. Let me just show you that in 3D so you can get a sense of that. I am so, so close, but not touching. And what I'll finally do for that last little piece is run this other thing called Flex Duct between the final little connection. And I can do that either in 3D or I can do it in 2D. I'll run Flex Duct, and I'll run it from the end here to the top of the terminal right there. And it'll put that little bit of, looks like dryer hose. Off in space. Control Z to get out of there. Might need to orbit that around a little bit. That's funny. Take you out. Take the transition out. Let me orbit this a little bit and see if I can try that again. I might have a better chance of getting it this time. So I'll go from the end here. I'm trying to get that top center, and I'm almost snapping on it, but not quite. Let me zoom in. It's funny, now it doesn't really like me. There it is. Okay, Flexi duct there. Again, Flexi, let me do it in 2D so you can sort of see it that way too. I'll take Flexi duct and just run it from the end here to the top of that. And it'll put it in there. So that's our supply side. It really is kind of that simple. You just got to run the main ductwork through, do the final connection, and it sort of takes care of itself. This is very similar to what we did with the plumbing systems, where I said, go ahead and sort of run the main lateral about where you want it to be, sort of give it the big design decisions, and then just do the connection at the very end in terms of where the terminals are, where the plumbing fixtures are to the main lines. Similar sort of concept. Get the main line down there and then kind of adapt. Let's go and do the other side of this equation. Over here, so supply side out here, now we have the return side over here. On the return side, we're also going to run some ductwork. Systems. I'll say we're going to run some ductwork. For this one, I'm going to raise it up a little bit higher. As opposed to being at 9 feet, I'm going to raise it up to 10 feet or 10 and a half. I want to sort of experiment with the idea that I could have the two things passing by each other. The truth is, if I design this really well, I might not have to have them passing over each other. I might be able to kind of just have the supply and the return kind of running parallel with each other. But that would be a very fortunate thing. I'm going to actually raise it up a little bit higher. Because you'll see when I do raise it up a little bit higher, again, I'll just sort of bring it on down. Oops. Now for this one, you'll notice I currently have it set up. A couple different things that are sort of interesting about it. A, it thinks it's a supply side, and that's because when I chose it, let me take it out. Ductwork. I want it to be return instead, so let me switch it over that way. The other thing is I still have it set to the mitered elbows. Let me go and put the radius elbows. Okay, so there's going to be some sort of air handler or something happening back over there. Now, the cool thing is if you have a little bit of vertical distance, you can see just how you're doing in terms of the vertical distance. Let me kind of rotate it a little bit. You'll see right now that that return side is a little bit higher than the supply side. You can sort of see over here how relative to the supply duct and their supply terminal, there's really not enough room in there to put some really good elbowy connection between there. On this other side, since I raised it up, I probably do have a little bit more room. It'll probably work. So I could go over here and in the same sense, if there is enough room to help it route, I could just go through and choose that and say, where'd it go? Connect into, and then choose a duct. And if it can, like that's enough room to actually sort of get the whole elbow in there. So if you do have room to say connect into it, makes it very simple. It'll put a hard line connection in there. Of course, that has to be a very precise connection now because it's a hard walled connection. Yeah, I don't have to do it that way. I could still use the Flexi Duct, whichever way I prefer. But the important thing I want you to know is that if you're having trouble connecting in, 9 times out of 10, it's just that the geometry just won't let you get the connection the way you want it to be. Okay, so it just is too tight. So in that case, I might need to switch to, as opposed to an elbowed system, a mitered system, or do something with a Flexi Duct. Either way will work. So same thing here. I could say choose you and layout connect into and bring it in that way. Or if I want to use that other strategy of using the Flexi Duct, I can bring a piece out. Looks like that one quite didn't join right. Let's see why not. I'm going to think about why that's not joining in a second, because it should. Let's think about that. Ductwork. Middle, level, that should be fine. Okay, that worked that time. It's actually pretty smart about what's going on. I wonder if there's sort of a minimum length that was at work there, or why it wouldn't let me do it over here from the center line. Okay, now it did. I just have to be right on the center line. Okay, so if I want to, I could use the Flexi Duct way to connect the end of that. Okay, in this case, it's complaining a little. Let's see what's going on. It thinks that either the Flexi Duct might be supply air. Yes, I need to make it a return air supply. Okay, now it's a little bit happier. So either way, I got supplies, I got returns running through there. So here's what I literally have to do. Okay. I got the supply, I got the return, it's coming back over here. I am driven by the number of terminals and moving enough air. I am driven by the whole issue of how am I going to get these things passing past each other in the night and still not somehow hit the beams that are running right above it. Okay, but what I will tend to do is actually go through and design this for one level, and after I got it working for one level, maybe even check to make sure that my beams aren't hitting it, then I can copy and paste it to the other levels. Okay, but it really kind of works that way. It's really not too bad. So what you're going to run into more than anything in terms of doing the systems design, it's not the engineering of the system, it's more just fighting the issue of the geometry. So if architects give you a very, very small amount of space to work with, you really have a struggle on your hands. If you have a very generous amount of space, no problem. It's easy that time. It's all just an issue of how much space. And people don't like to have excess space. It's this constant struggle about, how much space you do have and how you can squeeze your system in. Okay? So from the HVAC system design, it really is kind of that simple in a way. What's missing now, we have to put some sort of air handler in here that's going to introduce the heating and cooling and push the air through. And we can even size these ducts. Okay, but really that's pretty much where it's going. Okay, let me try this. Even in times of here, add insulation, add lining, duct pipe sizing, just so you even get a sense of this. There's this whole notion about how you want to size them. calculated size. Oh, I actually have to go put the air handler in that'll go through and put it in there for me. But you can basically go through and choose the whole system, and it'll figure out the size that it's necessary for every length. Okay, and that's actually pretty cool in order to maintain the pressure or whatever it is that you're using as your design criteria. Okay, so far so good on ducts. Sort of makes sense? Okay, if it does, let's transition into our last topic for today, which is model coordination. And that's really where this gets sort of interesting. And I think, like, for you guys who are in, like, the construction program, like, you've already been playing around with Navisworks. A little bit?
Yeah.
All dudes, Navisworks, stuff like that. Yeah, we'll play around with it some more in here, but, yeah, it's maybe sort of explain some of the things you didn't get explained. But we'll go ahead and kind of, like, take it into Navisworks and see where that goes. So here's the deal. We have been creating these model files. Oh, the architect created their model file. And in our case, our structural is inside our architectural model file, but that's okay. There might be two separate files that are linked together. The plumbing person might have created their own model. The HVAC person might have created their own model. We gotta get all these things together and make sure, because we've all been working so diligently optimizing our own good that somehow it all adds up into a cohesive whole and we haven't all basically tried to steal the same space. So that's really where we're going next. Okay, so we're going to pull our models together, integrate them, then we're going to run some clash detection to make sure that things aren't conflicting with each other too much. And the tool we're going to use to do that is called Navisworks. Okay, Navisworks has several different variations. There's something called Navisworks Simulate, which is all good for, what is it? It's really mostly good for doing 4D simulation. It's good for viewing things, but not so much for analyzing. Manage is kind of the big one, the big daddy that has all the different features in it. Okay, and if we open up Navisworks, see, it's not all that bad in terms of what's going on. It's a big old black screen. It's just waiting for us to bring some models into this environment. What we do is we append models into our environment. We pull them from other places. And when you're appending things, you got a lot of choices. I'll say append, and let's take a look at what our choices are. We have, we can bring in Revit files, we can bring in SAT files, or SketchUp files, or DWG or DWF files, or CATIA files. We've got a lot of different file formats we can bring in. And really, think of it, this is kind of like the Swiss Army knife of file merging tools. Everything is available here. And really the goal of doing this is, if you're working with a consultant who isn't working in Revit, this gives you ability to take their model file and your Revit file and get them together. So you can kind of just compare everything spatially. That's what it's really all about. So I'll stick with the Revit file format, and I'll bring in the architectural model, just so you get a sense of it. This is a little bit different. It used to be, up until a year or so ago, that you had to actually save things out in a special format called NWC, a Navisworks cache file. Now we can just open directly, so you have one less step involved. So here's the Revit architectural model. Not looking too bad. Okay, this architectural model we can play around with and explore if we want. So in this environment, we can orbit it and do things like that. We can go through and move in. So for example, I can do some walking. I'll walk on in. Looks like I'm a little tall right now. I'm up on the second floor. Let me go down a little further. More the first floor level. That's looking about right. And I'll walk on in some more. I'm a bad walker. I tend to crash through things. We have this ability within Navisworks to either sort of turn on collisions, turn on gravity or not, depending upon what we want. How that works is, let me kind of look up for a second and sort of see up into the atrium, kind of look around. If I turn on gravity, how that works is, I got to find where it is. It's under Viewpoint. Realism. I could turn on gravity, that'll drop me on down. Should drop me on down. Looks like collision turned on right now too. Let me do some walking again. Okay, I dropped on down to the ground. Watch out if you turn on gravity and you're outside and you don't have a ground plane, you may just go dropping down to the depths of I'm not sure where. So that's bad. Okay, let's walk around some more. I'm going to try not to fall in the hole. I want to get in there. Oh, I can't get in there. And why is that? Because I have collision turned on right now, and collision is keeping me from walking through things like doors. So I need to learn the keyboard shortcuts so I can do this better. But I'll keep gravity turned on. No, I don't want gravity, but just collision. There you go. Oh, come on. Oops, other way. Oh, it's interesting. I can't get gravity without collision. That's what it seems to be. I'll turn them both off. Go crashing through. I'm looking around. Okay, with just my architectural model, this is only marginally interesting. Okay, let me go on up to the second floor just so you sort of take a look at that. I'm going to go up. And because I can transcend time and space itself, I can go crashing through all these different things. I went too far. I think I'm up on the roof. There we go. I'm on one of the upper floors. This is so funny. I want to be there. That's that level. Looks like I'm clipping in some funny way. Hang on. Do some looking around for a second. No, I'm definitely up on the parapet. I'm trying to go down in a very limited way. Let's see what's going on now. Okay, now I'm at the second floor level. I can tell that. So I'm looking up, I'm seeing the suspended ceiling. I'm in the office space. Looking towards the corner window. That's where I want my desk. Okay, so I got this basic thing set up. I can merge together other model files. So, for example, I can go through and go back to home and append some other things. Let me get the structural model turned on. Okay, you saw some structural elements show up in there. I have some columns coming down. It looks like I have some beams kind of floating around up in here. I got some K braces over here. We'll think about where that's going to fit into things architecturally in just a second. I'm also going to go through and append the structural model, or the MEP model. Bring that in. Okay, and that doesn't look like we're seeing very much just yet. Okay, so I can bring all these different things together and sort of see how things are hooking up. Now, if I've done a good job, if I go through and have, all the different elements hanging around, I've got them all set up on the same coordinate system. They're all going to line themselves up very nicely. If they didn't, if you brought them in and they're just out of alignment, you can transform a model. You can push a model over. So we have something called the selection tree. It'll show you all the different models that are in there. And if necessary, we can go something where we transform a model. We can shove something over and push its origin over so many units X, so many units Y, so many units Z, just to kind of get them back in sync. Because if your consultants didn't all give you things coordinated to the same system, you can set that once and it'll remember it as they update their files every time. Okay, but since we got them all generated from the same system, we're in pretty good shape. Now, in terms of this model and what's going on, we have this notion of a selection tree. I can choose different elements like the structural elements. I can choose the architectural elements, or I can actually choose sub-pieces thereof. For example, in the architectural model, let me see if I can find the ceilings. Which level do they belong to? So you have ceilings on level 3. I have ceilings on level 2, or I have ceilings on the roof level. Okay, that's that one right there. If I want to go through and hide the ceilings, or some element of the model, I can just say, let's go through and hide it. Okay, and it'll turn that off temporarily, and then I can get a better look at really what's going on in the ceiling plane right now with all the structural elements in there. Okay, so again with the selection tree, I can really turn off whole classes of things. If I want to turn off the whole architectural model, I can. Now I'm just looking at the structural model. Let me orbit around a little bit. And there we have some ductwork running over on that side. This isn't the ductwork that we just did a few minutes ago. This is some ductwork that the student put in a couple of years ago. Let me walk on over and see if we can figure things out. Let me see if I can turn off that ceiling too. Actually, even in here, I should be able to. Is it in the structural model? I think the structural model, or no, the MEP model has some ceilings. That's where that one's coming through. Let me hide that. Okay. So I got that ductwork hanging around in there. And you might notice as you go looking through that we have a problem or two kind of set aside in here. You'll see there's a piece of ductwork. This, I believe, is kind of my supplier or my return. It's basically running on, and they, where it's located and where the beams are located right now are going to get me in trouble. They're basically trying to occupy the same space. So this is a problem. Okay, what do you do about this problem? Well, you can't just go walking around in the space and noticing things. Like, we could go through and say, okay, I'm at this view right now, and I would like to go through and save a viewpoint. Okay, and I have some, beam clashes with ducts. Okay, and I can save that. That way I'll be able to return to this pretty quickly. So if, for example, I switch my viewpoint and I do something else, now I'm looking down, and if I change back to that, it'll take me back to that viewpoint. So it's just saving a camera shot, like a snapshot. The nice thing though is a dynamic snapshot. So later on, if I fix something, I can return to this and see if it's still broken. Okay. The other thing I can do in this is, I can do some reviewing. I can go through and, I can, this, not good. This is bad. Can put that in there and send that over to you so you can go ahead and fix that now. Okay, but it's just really a way of communicating about what's going on with the models and being able to save those as viewpoints. Okay, but just wandering around in a model and just stumbling across things that are wrong, you'll find a lot of stuff. Architecturally, I always find a lot of stuff that isn't quite right just by wandering through and seeing things that aren't quite there. You might want a more systematic way to approach this, and they have that built into here. It's called Clash Detective, and let's talk about how you use it, because it's something that you'll want to know about. There are a couple big tools in here. Clash Detective helps you find spatial conflicts. Timeliner helps you do a 4D simulation. Quantification helps you pull quantities out and actually prepare the meanings of an estimate. But we'll focus on Clash Detective for right now. Clash Detective looks something like this. I'm just going to close those viewpoints over there. Clash Detective is all about the notion that, hey, we would like to be able to kind of just intersect different things and real quickly see if you can sort of figure out where things are overlapping each other. So as you're going through and clashing things, one of the things you probably want to do is actually, you could clash the entire structural model versus the entire MEP model, and you'll probably get a lot of things that are valid clashes. You'll get some things that aren't really valid clashes, just little sloppinesses in the way we model things where things are overlapping, only because we don't actually put a punch out or a cutout every time we have a beam intersecting with a ceiling plane or something like that. So figure out that there's valid clashes and there's clashes that are allowable clashes. So we can intersect entire models. I'll just do that tonight because it's quickly. Next time we'll do this with more control. We'll intersect just a piece of the model. So as opposed to the entire structural model with the entire MEP model, we'll say, how about if we just get those horizontal beams versus the ducts? Because then it would give us a smaller list of clashes, something we can control a little bit more. But for now, I'm going to add in the test. I'll add in an initial test, and this is going to be, this is a big, gross clash test, okay, which is everything. Okay, you'll see there are currently no clashes right now because we haven't defined anything. But if I want to compare, for example, the structural model to the MEP model, okay, just set them up side by side in terms of what we want to compare with each other. I can say run the test, and we can think about different types of tests we can run. There are hard tests where things actually physically have to intersect. There are clearance tests where things just have to be within a certain range of each other to report a problem. And that might be useful if you need a certain amount of space around some insulation or around some ductwork. If you need a clearance around things, you can do a clearance test and it'll say, is anyone violating your bubble? Is it getting within the clearance zone that you're setting up aside or around something? Duplicates actually find like two objects that are just physically in the same place. But I'll go for a hard test right now. We can say what the tolerance is, as in it has to intersect more than a certain amount to be considered a clash. So that's that whole issue. Will you allow things to butt up against each other, or do they physically have to be intersecting each other? I'll run this test. See what's going on. It's found 87 things right now that it considers to be clashes right now. Okay, in the scheme, that's not too bad. Yeah. As we go through and look at them, you'll see that there's all sorts of variations in here. See if I can sort of highlight some of them and show you what they look like. My screen is very squishy because of the way it's on the projection system here. But if I go through and choose any of the clashes, what'll happen is a couple things will happen. Down here at the bottom, it'll actually show me what the elements are. So I can see that there's some W14 by 30, which is conflicting with some rectangular duct. And over here, it's going to show me, looks bad, that seems to be an issue. Okay, that's a good one. So I need to go through and probably assign something to this. In terms of its status, it's still new. Okay. In terms of, assigning it, let me go ahead and assign this to, I'm going to assign this to Glenn, and this is going to be one of my must fixes. Okay, go on down. Looks like another one where we have something like that. I might have a bunch that are going to have this sort of characteristic to them. I'm going to go up to the top. You'll see some things that aren't so bad. In this case, what's happening is there's some piece of structural bracing which is intersecting with the ceiling plane. And that's actually okay, because what's happening is I just didn't do a very careful job about modeling on the ceiling where the structural piece would intersect it. So you're going to learn to sort of distinguish between allowable clashes and clashes you care about. Kind of group the ones that you care about. It's going to pull on down here. What's down there? That's some wall intersecting with a structural framing. I'm not going to worry about that too much. Again, what do we have in here? Some sort of structural framing with a duct fitting. That'll be one of those ones that, again, I'm going to assign to me. Or some note that might be a little bit better in terms of what's going on. So I start creating this sort of list of things that need to be fixed. We can tally them up there. Okay. If I go through and create a list of all these different things that I want to go through and tally up, I can go through and produce some sort of report to help me understand what this is all about. I'll switch to the report tab, and I can go through and create a report. So I can create a report of a current test, or I could actually run a whole bunch of tests, which you're going to find out that in industry what they do is they'll run instead of opposed to doing the entire structure versus the entire ductwork, they'll do all these little teeny tiny pairwise tests that are easy to control. Just the ducts versus just the joists, just the ducts versus the major girders. And we'll sort of do that in smaller sets where the things you are checking are based on who's likely to have to resolve that type of issue. Because it really gets down to just creating a bunch of issues and controlling that. Okay, so I'm going to say the current test here. I'm going to give it a report format, XML, text. I actually like HTML as a format. I'll say write a report. I'll put it out there somewhere like on my hard disk. It'll write a report for me, and the reason I want to create this report is that later on I can send it to you and let you know what all my clashes were. Or I can subset this a little bit so I only print out the ones that are assigned to Glenn or assigned to any specific person. That way you have some control over, who gets what list of clashes that you want them to take care of. But once I go through and create something like that, go to Documents, see if I can find this thing. Descriptive names like big gross clash test in furniture dumb block. Okay, open with, let me bring it up in Chrome. Okay, So what it is in here, for each of the different clashes, it'll tell you, what is the element, what is the type, how do we find it, how big the clash is, as in how much the intersection is. And we can, structural columns and acoustical ceiling tile, I'm not going to worry about. I probably should knock that out and just say that's allowable. Structural columns versus, some solid. That's interesting. Rectangular ducts versus that one I'm going to care about. So what I can do is, back over in Navisworks, there's Revit, and the Navisworks. Did I close Navisworks? Where'd it go? That's funny. I think I closed it. We could run that clash test. We can go through and assign or decide that things are not allowable. Let me go ahead and just append those in there again real quick, and I'll save this away, and we'll be done for the night. Okay, I'm going to append those things. Let me bring in that structural. And let me bring in that MEP model. Okay, beautiful. So again, I can run the clash tests. Add a clash test. Run this, run that. I got more stuff that wasn't hidden this time. If I go through and I want to decide that some things are allowable, I can change the status. For example, it's reviewed, it's approved, it's resolved. I can sort of like just decide, I've reviewed it and I just don't care about it. And then I don't have to worry about it. It won't necessarily show up in the report. Okay, so after you go through and you create these clash tests and you're feeling pretty good, if you want to share this with other people, what you can do is as follows. You can save this away. We have a couple different formats we might want to save things away in. A Navisworks file set is this. It is a series of coordinated files where the files are still externally linked to it. Okay, so a Navisworks file set is really, really useful when you want to sort of give someone kind of the results of your clash work, whatever tests you set up, but you want to allow that the files themselves are still separate. They can still change, okay, because it's just really links to files. They'll always be updated as we kind of keep on going. Okay. The other set you might want to consider is an NWD file, which is actually a Navisworks document. That's actually locked in time. So what that does is it doesn't put links that are active to files. It actually stores the data that is currently loaded in there as a snapshot today in time. Okay. The nice thing about that is if I want to compare what's happening today with what happened 2 weeks ago, an NWD file gives me that snapshot from 2 weeks ago, so I can recreate exactly what the files were, what the states were, what the clashes were at that point in time, and I can then kind of take a look to make sure I'm making progress. So the big changes are NWF, great for live, active, have access to the files. NWD, snapshot in time, locked in time. But the other good thing about NWDs is I can give you an NWD and then you can look at it, okay, but you can't really change anything inside of it. It's locked in time, okay? So it's not a bad way of sharing things with people when you don't want them to be able to change them on you. So watch out for this. As you're taking some of your construction classes and people say, oh great, I'll share my model files with you, I'll give you the NWD file. Okay. It's so tantalizingly close because you can look at it, you can see it, you can rotate it around, but there's no way of actually going from an NWD file back to opening the Revit file. Okay, because it really is just that locked in time and space version of it. So watch out for that. When people are sharing files for you, there is a difference between NWD and giving you the Revit or the NWF file. Okay, so yeah, we always hit that like in winter quarter when you're starting to work in like 211 and people are bringing in different project files that are being shared by consultants with you, and you wish you could open them, but you can't because they just gave you the NWD. So you have to go back and ask for the original Revit file too. Okay, so watch out for that one. Okay, super. Let us adjourn for this evening. And when we continue, what we will continue with is we'll keep on playing with systems modeling, and or not that. Nah, we're done with that. We're going to continue playing with clash detection, how to get better about using clash detection so we have some more control over what's going on there. And we'll also look at how we can use this tool to create a 4D simulation. Okay, so let's leave it at that. Yes?
So, NWF file, so let's say I did some clash detection today.
Yes.
And then I gave them those 80 clashes, they fix things up in it.
Yes.
So if you edit things in the actual files,
Yes.
will they change automatically in the Navisworks file without re-appending them?
What'll happen is, very good question. The NWF file keeps the links open. So I like to keep an NWF file around, which is kind of my current dashboard of things that I'm sort of checking on. So I say, please go fix your Revit file. You send me back the Revit file. When I reopen my NWF file, I can rerun the clash test. Okay, and all the appending's done already, all the transformations are done, all the setting up the clash tests are done. So when I rerun the clash test, I'll hopefully see 80 drop to 20. Okay, and it's a live connection that way. So what happens is in the job sites, when people are doing this, they'll work with the NWF file all the time. And they'll always kind of keep the file names just the same so that as you keep on swapping in newer versions underneath it, it'll always have the current state of things. You can always back up because what they'll do is they'll keep the NWF as the current, okay, and then every day or every week we'll save an NWD as the archive file so that you always have just a snapshot in time. But let the NWF be your constantly current one because if you keep it current and open, it'll always be updated with whatever the current state is. Does that make sense?
So do you have to reinsert the files? Or is it
Nope. The NWF it understands it's looking for architectural model.rvt, and if I needed to do some transformations, it remembers what the transformation is. So tomorrow, if you change architectural model.rvt, when I look at my NWF file, it'll pull your more current information automatically. So it does it every time I open it. So it's really cool because it stays live.
Okay.
Yeah, so it does what you want it to do. Okay, which is, so set them up and then you don't have to keep on reappending. If you do this right, you'll only have to append and transform once. Okay, and then like every time you open it, it'll always be up to date. Okay? Okay, Edie, let us break.